In my last video, we discussed how to find the variance and standard deviation for a discrete probability distribution. You can see all the work here. But we're just going to run through a couple of examples really quickly to get used to this formula, this idea that the variance is equal to this business up here. We say the sum of our squared data times their probabilities minus the mean, okay, where the mean, remember, is defined as being the sum of just our regular data times their respective probabilities. So let's go ahead and start with number 6 here. It says 5 balls have numbers on them, 0, 2, 4, 6, and 8, and they're placed in a bag. It says after they're mixed up, one is selected, we note its number, and then we put it back. It says if this experiment is repeated many, many times, matter of fact, if we were to do this for eternity and keep track of what we keep getting as the number each time, what I want to know is this: what are the mean, variance, and standard deviation for the numbers that show up on these balls? So we're going to let x equal the number on each ball. The very, very important thing to do here is start off by making your probability distribution. So for instance, our probability distribution, when we construct it primarily, we say I have x and p of x, but we say 0 could happen. We could draw a 2, we could draw a 4, we could draw a 5. Phew, got caught on that one. 6 or an 8, sorry. But these are the possibilities. In order to find the variance and standard deviation, let's keep this in mind, we're going to have to find the mean first. And the reason why is because the mean involves or the variance involves the calculation of this mean. So if we're going to find the mean, let's go ahead and add in this row down here where we take x times all the probabilities for x occurring. Okay, so these probabilities we're actually going to have to find. They're not so bad to find, as a matter of fact. The reason why is because each of these has a 1 in 5 chance of being pulled out of the bag. So you say 1 in 5, 1 in 5, 1 in 5, 1 in 5, and 1 in 5. So if we're going to find the average of this, the first thing we're going to do is we're going to take all the x values times their respective probabilities. That is, we'll take 0 times a fifth, and we'll get 0 fifths. We'll take 2 times a fifth and get 2 fifths. 4 times a fifth, get 4 fifths. 6 times a fifth is 6 fifths, and 8 times a fifth is 8 fifths. And so now to find the mean, we just sum these up. So the sum of these is going to be in fifths. We say 8 plus 6 is 14, plus another 4 is 18, plus another 2 is 20, and 20 plus 0 is 20. So we get 20 over 5. In other words, the average number, okay, is 4. So, if the number is 0, 2, 4, 6, and 8, 4 is, on average, the number you're going to see the most often, okay, or the value of the ball. So now to find the variance and standard deviation, here's what we're going to do. We're just getting into the habit of doing this. We're going to add in 2 more rows, okay? And these rows, the top one at least, we're going to put in our squared data values. So we put it on top because it's right next door to the original data values. So like 0 squared, we get 0. 2 squared is 4. 4 squared is 16. 6 squared is 36. And 8 squared is 64. And then we're also going to build in a column down here where we take now not our data points or everything that can happen times their probabilities, but the squared data times the probability this happens. Okay, so we're still going to take these probabilities and multiply, but we're going to multiply them by x's squared. So for instance, we're going to take 0 times its probability. So we get 0 times a fifth is 0 fifths. If we took 4 times a fifth, we'd get 4 fifths. 16 times a fifth would be 16 fifths. And so on and so forth. 36 times a fifth is 36 fifths. 64 times a fifth is 64 fifths. What we need to do now is find the sum of these, okay? Because we're going to need to use this in order to find our variance. That is this value right here. So that being said, we say how many total fifths have we discovered here? Well, we say 36 and 64. Nice, that makes 100 actually when you add those. 116 plus another 4 is 120 plus 0 is 120. So 120 fifths, and we actually turn out a number 24 here as a nice integer. So in order to find the variance, recall that variance is this lowercase Greek letter sigma squared, but we say it is this. It is this larger of the two numbers, so this 24, minus the average. So we now need the average here, which we had was being 4. And so we say squared. So we get this. We get 24 minus 16. So in other words, we get 8. And this right here is our variance, okay? So if this is our variance, we need to find the standard deviation. So the standard deviation would be the square root of this. In other words, you get 2 root 2. Or if we were to pull out a calculator and ask for a number that's not in exact values, we could say 8. We want the radical of this, so 2.83-ish. So we have about a 2.83-ish standard deviation for this data set. Okay, let's try one more really quickly here. It says the probability, this is like data driven here, the probability that 0, 1, 2, 3, or 4 people will be placed on hold when they call it radio talk shows in the distribution. So like if we kept track of how many people we had on hold when people call in, we'd say, on average 18% of the time we get 0 people on hold, and 34% of the time we got 1 person, and 2 people, 3 people, 4 people on hold. You can see their respective probabilities here. Honestly, we'd say most of the time you're going to have like 1 or 2 people on hold is what I'm guessing, somewhere in there. But it says find the variance and standard deviation for the data. Okay. So here's the deal. We say, well, first thing we're going to need to find is the mean. We actually already have our distribution constructed here. So I'm going to extend our table here to include a few more things. So if we're going for the mean, that means that we need to include this, x times p of x. So we'd say, well, 0 times 0.18. Well, we get 0. 1 times 0.34. Well, we get 0.34. If we took 2 times 0.23, we'd get 0.46. If we tripled 0.21, we'd get 0.63. And if we quadrupled 0.04, we'd have 0.16. So our mean, which is the sum of all of these, would be what we get when we pull out a calculator here and we add all these up. So we have 0.16 plus 0.63 plus 0.46 plus 0.34 plus 0. And so if that's the case, we get 1.59. So we say 1.59 on hold. So on average, we have about 1.59 colors on hold. My question is, how spread is our data? Give or take how much? So in order to find this, we're going to have to extend our table again, and we're going to find now not x times p of x, but x squared times p of x, okay? And then up here, we'll put our squared data values just as we've done before. So we get 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. And now we're going to take all of these times their respective probabilities right across the board here and then sum them. But we get 0 times 0.18. Well, that's 0. We get 1 times 0.34. Well, we still get 0.34. But if I took 4 times 0.23, let's see what we get here. We get 4 times 0.23. It's 0.92. So 0.92. We get 9 here times 0.21. So 9 times 0.21, so 1.89. Oops, let's put the decimal in, 1.89. And then 16 times 0.04, just to speed this up a little bit here, you get 0.64. Sorry, I did that one in my head. So now we need to sum all of these and put it on the right here. So we have our 0.64 plus 1.89 plus 0.92 plus 0.34 plus 0. So we get 3.79. So we say this sum down here is 3.79. So again, just like we have calculated variance in the past, we say, well, then our variance would be the bigger of these two values minus the square of the smaller. In other words, we'll take this 3.79 and we will subtract off the square of 1.59. Okay, so we could get our calculator back out. We say, all right, well, 3.79, let's take off, and I'm going to put in parentheses 1.59, and I'm going to square it and end that parenthesis and then subtract that off. So I get 1.26-ish. So we'd say 1.26, this is our variance. Okay, and again, to find the standard deviation, we always take the square root of the variance. So we'd say now our standard deviation, sigma, is the square root of 1.26. So we'll get our calculator back out. And we'll say, let's take the square root of this, which is 1.12-ish. Okay, so 1.12-ish. And we do want to label this on hold. People. Let's say people on hold, I suppose. But basically what this means is, on average, we should expect about 1.59-ish people on hold, give or take about 1.12 people. Okay? But that is how you calculate the variance and standard deviation for discrete probability distributions. Cheers.